So it's time for round 2 of word problems. We have our first of mixture, and these are investment problems. Big thing to know about investment problems is that the amount you make is less than the amount you start with. That is very, very, very important. The amount you make is usually less than your starting amount. That would make sense. I mean, you start with what you have, and then you make more on top of that. You don't put $4,000 in a bank and suddenly come up with $10,000. That would be a weird economy, which we do not have right now. So let's start this. You have $4,000 in tax-free bonds. You don't have to know what a bond is or anything about this. All you have to know is that you have $4,000, and you're putting it in a tax-free bonds that pay 10.5% annual interest. That is our rate. That's going to be very important, kind of like our rate times time equals distance. And then it says, at what annual interest rate do you need to invest $1,000 in a certificate of deposit to achieve an average interest rate of 10%? So let's do the first hypothetical. We have tax-free bonds. At the top, I'm actually going to start with not rate times time. I'm going to put the rate in the middle. It's just kind of customary in these tables to do that. And our rate here is going to be a percent, an interest rate. Then we're going to have amount invested. This is like the amount that we start with. So we invest $4,000. It pays 10.5%. That would be expressed as 0.105. 0.105 is the same as 10.5%. And then much like we did before, we have amount invested times rate. We get the interest earned. So I'm going to do 4,000 times 0.105, and that gives me an answer of 60. So my interest earned on that was $60. Then the next case was we have certificates of deposit called CODs. The amount invested is $1,000. At what annual interest rate? We don't know that, so we're going to call that R. And the interest earned is 1,000 R. So what does this leave our last one? Well, this is going to be an average. Average amount invested, well, average slash total. I mean, that's kind of the thing about it. This is really a total. If we're going to use an average, think about how you take averages. You add up and then divide by the number of numbers you have. So we're going to add these two up to give us 5,000 total invested. And this is like taking into account both of these things. I'm going to put almost even like a bar here to separate this so you can kind of see this. Our average interest rate was 10%, so that's 0.10 for our average total column. And 10% of $500 is 500. Then as I talked through this, I realized that 10.5% of $400 couldn't possibly be 60. 10% of $4,000 is 400, plus another 0.5% would be 200. That would be 600. I'm going to confirm that just with the calculator one more. Yep, I messed it up. So 4,000. Oh, I got to clear it. 4,000 times 0.105. 420. Okay, I should not get into mental math right now. That'd be 420. Okay, that's right. So how do we figure this out? Well, here's our equation right here. Our interest earned should be a total that matters here. So we have 420 plus 1,000 R equals 500. If I subtract, I get 1,000 R is equal to, that would be 80. And so then R is equal to 80 over 1,000 would be the same as 8 over 100. And 8 over 100 is the same as 8.08. That's right, which is the same as 8%. So the CODs should be at 8%. Okay, moving right along. Robin earns 1.5 times her regular wage for overtime. After working her usual 40 hours last week, she worked an additional 8 hours of overtime. She made $871 last week, find her usual hourly wage. You often have to look very carefully at the two things that we're going here. We have two different rates, and that's the trick. Up above, we had two different rates for deposits. Here we have kind of a regular wage, and then we have an overtime. So I'm going to use this to be regular, and this is going to be overtime. I'm going to still have a rate, and that's going to be not really a percent, but this is going to be, usually it's dollars per hour. And that's important. Before it was a percent, but this rate was expressed in dollars per hour. If it's dollars per hour, then our first column should be hours worked. And this is really where you can start to see that we actually switched the whole rate and the time column. This would be sort of like time, and this would be sort of like rate. I don't know, we just did this because this is sort of how we usually do it. It doesn't matter if you have the first two columns in a different order. It's still hours worked times rate is going to be equal to total money, which we can call total income, or wages, or whatever you want to call that. Robin earns 1.5 times her regular wage, which we'll call R. 1.5 times that, I like fractions, it's going to be 3/2 R, 1.5 R. I really don't care here if you use a decimal. After working her usual 40 hours last week, so she worked 40 regular hours, she worked 8 hours of overtime, and she made $871 total last week. So we are going to have like a little total column here too, or total box. Now we're just multiplying. 40R. 3/2 times 8 is half of 8 times 3, so 12. And we get 40R plus 12R is equal to 871, or 52R is equal to 871. And that means R is equal to, so if I pull out my calculator and do that division, it's R is equal to 16.75. So she earns $16.75 per hour. That's her regular wage. Let's go to Yoda. Yay, Star Wars. Yoda apparently has money in these days. He invests part of his $16,000 at 6.5% and part at 8%. So we have a 6.5% investment, and we have an 8% investment. And then I'm going to sort of change these over and say, well, that is 0.065, and the other one is 0.08. And that's going to help us start to fill these things. We have a rate expressed as a percent. Yoda invests part of his money, so we have amount invested. Yeah, you can leave out the dollar sign, because I assume we're talking in dollars if you don't put anything. This is the US of A, but you know, if you're using euros or cents or something, you got to put that. And then we have investment income. So we invest an amount, we multiply it by an interest rate, and then we have the income earned, or the interest earned. So I'm actually going to change that. We're going to say this is called the interest earned. We should earn less interest than we invested. Furthermore, we invested $16,000. That's a total. So I'm going to have a total column here, or a total box here. 16,000. I don't know anything else about the rest invested, so watch the trick we do. X and 16,000 minus X. We've done that before. That means that we're kind of accounting for the 16,000. Furthermore, it says my total investment income is that. Is 11,075, or 1,175. Okay, everyone, if you've hit this point in this video, hit pause, and then compare for like a minute what's this doing and what's that doing. Why is your interest earned less than your amount invested? Does that make sense? Can you remember that it's going to be like that no matter what? Because the number one thing people mess up here is forgetting or not figuring out where that goes. They want that to go here, and it can't. That's how much you make. Now, granted, you still have the original $16,000, otherwise investments would be pointless.
but this is how much more money you make on top of that. So that's what this is kind of getting at. Okay, hit pause, reflect on that, come back to me. You're back. Okay, multiply 0.065x. Then you have 0.08 times 1600. I'm going to pause and do. You get 1280 minus 0.08x. So at this point, if you don't have a calculator out, let's get one out. You can use your cell phone calculators for this, but you probably should charge your TI Inspires so you've got them for a test, because this does require calculators here. It doesn't require it, but it really, really helps. Okay, so let's add these up now. And we have 0.065x plus 1280 minus 0.08x is equal to 1175. Add your like terms, we get negative 0.015x. Subtract the 1280 over, and we get, this is hard to do mental math right now. Okay, that'd be negative 105. Divide, I'm going to do this really quick here, so I don't have to pause this. And 105 divided by 0.015, and I get x is, stop it, x is 7,000. And then it says how much did you invest in each rate. Yoda invested 7,000 at, x was the 6.5%, so 7,000 at 6.5%, and 1,600 minus 7,000, 9,000 at 8%. The Muppets, my favorite people, invested 1/3 of their money at 6.5%, 2/5 at 10%, and the rest at 8.5%. If their annual investment income is this, how much do they invest altogether? Okay, so this would be the 6 1/4%, this would be the 10%, and this would be the 8.5%. Convert those to rates, 0.0625, 0.10, and 0.085. That would be the rate expressed as a percent. This would be the amount invested, and this would be the interest earned. Follow me so far? So we've got three different rows here. This is new. We're also going to say we have a total amount of money, and that's going to be x. That is less important, because what we're really doing is we're having all of these add up to x. 1/3 of their money is 1/3 x at 6 1/4%, 2/5 at 10%, and the rest at 8.5%. Well, funny thing, we can do 1 minus 1/3 minus 2/5. I want to figure out what that is, so I'm going to express this as 15/15 minus 5/15 minus 6/15. Convert them all to 15ths, and I'm left with 4/15. That's how much is left over, so 4/15 x would be my amount left over. It says that the total annual investment income, which would go here, is 1753.5. Then I have some multiplication to do. So, let's see. I have 0.0625 times 1/3 x, 0.10 times 2/5 x, and 0.085 times 4/15 x. Okay, calculator out. Or before we do that, can we do the whole LCD thing? If I write this one more time and add all these up, let's see, plus 0.085 times 4/15 x equals 1753.5. I'm going to have a little bit of a problem with 1/3 of this without running into decimals. So I could multiply the left and right sides by a 15. That way my numbers will be bigger, but at least I'll have stuff that's a little bit easier to work with these numbers here. So let's do that. Let's do a multiply the left and right sides by an LCD of 15. So I'm going to multiply by 15 to clear those fractions. I'm just going to do it with these little parts here. So I'm going to keep the 0.0625. That's going to become 5x plus, in the 0.1, we have 2/5 of 15, which is 6x, plus 0.085, 4x, equals, and then I have 15 times 1753.5, because I multiplied the left and right sides. Now I have a little bit easier numbers to work with, and I don't have these fractions, so that's good. Then I'm going to do 5 times 0.0625, which gives me 0.3125x, plus, it's going to be 0.6x, plus, then I have 4 times 0.0825, and that's 0.33x, and that's going to be equal to, and 15 times 1753.5, or 26302.5. Add all these up, so 0.3125 plus 0.6 plus 0.33, and I get 1.2425x equals 26302.5. Then 26302.5 divided by 1.2425, and I get an x that I'm going to have to round. It's something like 21169.0, and we'll round up just to be safe. That. So I'm just going to circle this. That is the amount of money that they invested all together, assuming I did this all right. So, okay, that's it.